Hi everyone, here are some tips that could be useful helping you to finish the back page of the torque worksheet, aka your homework. So for the first problem, we have the table, and with any kind of torque scenario, we need to look for sources of potential rotation, or what are the forces of being applied to this object that making it potentially rotate. So we have the idea that a person is going to sit on the side and not have it tip over. So let's just look at, what if a person sits on the very edge of the table and it does flip over? Around what axis is the table going to rotate? So what's going to happen is this person is going to obviously apply a force, just going to create a torque. So that's the weight of the person. And this left leg is going to lift up and it's going to pivot on that right leg. So we can look at this point really being our axis of rotation. So there needs to be something on the other side of that axis to counteract that clockwise rotation. And in this case, it's going to be the weight of the table itself. So since we're assuming it's a uniformly made table, the weight of the table is going to act right in the center, right at the center of gravity or center of mass. So it's going to act right at the 1.1 meter mark. And that's going to be the weight of the table. So we have two torques, one caused by the weight of the table, one caused by the weight of the person, where the weight of the person wants to make the table rotate this way, and the weight of the table itself counteracts that as long as the person sits at the right spot. So go ahead and continue with that problem with the note that now you know where the two forces act. Part 3, I think, is kind of a little bit easier. It's just you now have 3 people on that same seesaw. Something that's going to be a little bit new is the third example, or third question, because now we have angles. So what we have here in this problem, we have this pole that's holding up the traffic light. This is our object that's going to rotate around this axis A. So let's start just identifying forces that are acting on the pole. So one, it's going to be the weight of the light. I'm going to call it FGL, L for light. So that's going to create a torque, making the pole want to rotate this way. We also have the tension in this cable that's attached to the pole that is preventing it from rotating. So that is a torque that's going in this direction, opposing the weight of the light. And we actually have a third force, the weight of the pole itself. So if we just had this pole and no tension force and no light, it would still fall over. It would pivot around that axis A. So since this is a uniformly made aluminum pole, the center of gravity, or the center of mass, is going to be right in the middle. So if it's 7.2 meters long, it's going to act right in the middle. So we have that force of gravity of P, meaning the pole. So now we have 3 torques. So we're going to have the torque from the tension in the pole acting counterclockwise, and that's going to equal the sum of the other two since they're acting in the same direction, meaning clockwise. And I'm going to say torque of the pole plus the torque of the light. And again, just as a little aside, torque is Fr, and if there's angles involved, sine theta. So we do have angles here, meaning that these forces are not perpendicular to our what's called lever arm, our object that's being rotated. So we need to find out the forces or the components that are perpendicular. So we're going to be looking for these forces. So to figure out for the component of tension, we're given that angle, 37. But what you're going to need to do and the challenge for the homework partly, is to find out what these angles are here. There is enough information in this problem for you to determine that, so you can plug that into your equation here. So make sure you note down any questions that you have so that you can ask next class.